Hi and welcome back. This time we're going to solve differentiation problems or exercises using the chain rule when we have transcendental functions. So what are you waiting for? Let's get started. Now, you will see on your screen here the composition of functions e raised to the x squared. Now, again, it is essential to identify first what we have. First, we know that there is a transcendental function here that is e raising something to e. You have the presence of an exponential function. And also, you know that you are raising e to a function, which is x squared. So, can you tell me what's the inner function here and what's the outer function? Right. The inner function is x squared. Meanwhile, the outer function is raising e by something, e raised to u. Now, to use the chain rule, okay, so how do we find f prime x? Sir, f prime x is just the derivative of the outer function. But you remember, what's the derivative of e to the something? Sir, I know, it's e to the something. Correct. It's itself. The derivative of e to x squared is e to x squared. But by the chain rule, we have to multiply this with the derivative of the inner function. Now, what's the derivative of the inner function? Sir, I know. That's 2x. And right you are. So, indeed, the derivative of f of x is 2x e raised to the x squared, and we're done. Okay, let's move on to another exercise. We have here number 5. Sir, I'm seeing another transcendental function. Right, you are seeing here the natural logarithm of something. So can we identify what's the inner function and the outer function? Yes, of course, sir. The inner function is square root of x, but the outer function is ln of something, in this case, square root of x. So let's find the derivative using the chain rule. Sir, f prime x will be the derivative of the outer function. So what's the derivative of ln of something? Sir, I know that's 1 over something, correct? 1 over whatever that's inside ln. So sir, in this case, it's square root of x. Now, times the derivative of the inner function. So what's the derivative of square root of x? Sir, the derivative, okay, so let's do something else first here. Sir, the derivative of square root x is the derivative of x to the 1/2. Sir, by the power rule, that is 1/2 x to the 1/2 minus 1, which is negative 1/2. So, sir, the derivative of square root of x is 1/2 times x to the negative 1/2. Sir, this means that, or rather, further simplification tells me that this is 1 all over 2 square root x. Or, finally, this is 1 all over 2x. And we're done. Sir, could we have done this without using the chain rule? I think we could. Let's see here. Okay, so this uses chain rule. We could have perhaps done this by simplifying first f of x. We have f of x is equal to ln. Square root of x is ln x to the 1/2. Now, if you can recall, we have a properties of logarithm that tells you that this is actually equivalent to 1/2 ln x. Okay, you bring down the exponent of the argument inside ln as a factor. So that means 1/2 instead of ln of x to the 1/2, it becomes the 1/2 of ln x. Okay. Which means that we can use your old differentiation rules to give you this is 1/2 times the derivative of ln x, which is 1 over x, which is indeed 1 over 2x. You will see that our answers agree. Whether you did chain rule or whether you did expansion via a property of logarithm, you will still get the same answer 1 over 2x, which is a good thing. We are able to check whether we got the right answer. Now, shall we move on to the next? Sure. Right. So we have here the problem. Sine of 2x cubed. Can you identify the inner and the outer functions? Yes, sir. The inner function is 2x cubed. The outer function is sine of something. Okay, in this case, 2x cubed. So, by the chain rule, f prime x will be the derivative of sine u. Anyone who remembers the derivative of sine u? Sir, that is cosine of u, okay, or whatever that's inside. In this case, it's 2x cubed. Times the derivative of 2x cubed. Sir, that's 6x squared. So finally, we have the derivative of f is 6x squared cosine 2x cubed. And we're good. Sir, could we have done this without the chain rule? I'm afraid not. Okay, so there's no other way. In this problem, there's no other way but really to use the chain rule. Okay. Shall we move on to the last two problems? Sir, we have here the tangent of x cubed minus 2x plus 1. Again, we just have to determine what is the inner function and what is the outer function. The inner function is x cubed minus 2x plus 1. And the outer function is the tangent of something. Of course, in this case, that something is x cubed minus 2x plus 1. So, by the chain rule, f prime x will be, what's the derivative of the tangent of something? Sir, I remember that's secant squared of something. So in this case, I just copy x cubed minus 2x plus 1 times now the derivative of the inner function. Sir, that's 3x squared minus 2. Correct. And stop here. Okay? Or you can further expand this to say this is 3x squared secant squared of x cubed minus 2x plus 1 minus 2 secant squared of x cubed minus 2x plus 1. Either ways, okay, either this expanded form or this one above are perfectly fine. All right, so when comes the assessment or examinations, either ways will just be fine. Right, so let's move on to the last example. We have here the function cosecant of e raised to x. Cosecant of e raised to x. So we have here the inner function. The inner function is a transcendental. So this is a case when you have a transcendental within another transcendental. So the inner function is e to the x. The outer function is cosecant of something. In this case, it's e to the x. Now, the derivative f prime x will just be, first, the derivative of the outer function cosecant of u, which is, anyone who remembers what's the derivative of cosecant u? Right, that's negative cosecant of what's inside, which is e to the x, times cotangent of what's inside, e to the x, times, all right, so we're done differentiating the outer function. What's the derivative of the inner function? So the derivative of e to the x is also e to the x. And so there you have it. The derivative of the composite function cosecant e to the x is just negative e to the x cosecant e to the x cotangent e to the x. And we're done. So I hope that after these examples, you realized how to use the chain rule to differentiate functions that are compositions, or when you have an inner and an outer functions. I hope you realize that it is very crucial for you to know what's the inner function and the outer function, because everything follows from there. Do you have any questions? If you have, just email them to me or line them to me so that I could answer them. That's it for now. Thank you for watching.